Hello, my friend, and welcome. Tonight, we are going to lie back together, let our shoulders sink into the pillow, and drift very slowly out past the porch light, past the rooftops, past the last hum of traffic, into the dark and quiet dome that has been arching over every single night of every single life since the first human ever looked up. There is nowhere to be. There is nothing to solve. There is only the sky, patient and enormous, waiting the way it always waits, and your breath, slowing the way it always slows when a story is gentle enough to trust. Let's start with the dark itself, because it is easy to think of the night sky as empty, as a black nothing with a few lights scattered across it, but that darkness is doing something. It is a stage curtain, still and heavy, that lets even the faintest light through. When you stand outside on a clear night, far enough from streetlights, your eyes begin a slow unfolding, a kind of soft blooming that takes about 20 to 30 minutes to fully happen. The pupils widen, the light-sensitive cells in your eyes called rods wake up more and more, and colors fade away while shapes and brightness sharpen. This is called dark adaptation, and it is the same quiet process your eyes go through right now as you feel your own eyelids grow heavy. Astronomers protect this adaptation almost like a sacred thing. They use red flashlights instead of white ones, because red light disturbs the eye's night vision the least. So if you ever see a person standing in a dark field holding a small red glow, they are not being mysterious. They are simply being kind to their own eyes, the same way I am being kind to yours right now by keeping this voice low and slow. Above that darkness float the stars, and the very first thing worth knowing, the thing that makes the whole sky feel like a gentle time machine, is that starlight is old. When you look at a star, you are never seeing it as it is right now. You are seeing light that left it years ago, sometimes decades ago, sometimes centuries, sometimes so long ago that entire civilizations rose and fell while that light was still traveling toward your eye. The nearest star beyond our own sun, a small dim red star called Proxima Centauri, is a little over 4 light years away, which means its light takes about 4 years to reach us. Look at the brighter, more famous stars in the winter sky, like Sirius, the brightest star as seen from Earth, and its light is about 8.5 years old by the time it lands on your retina. Somewhere in that soft blue-white twinkle is a memory of a slightly younger version of the universe. You are not looking at stars. You are looking at their past selves, patiently arriving, one photon at a time, like slow letters finally delivered. And that twinkling, the shimmer that makes stars seem to tremble while planets tend to glow steady, is not something happening to the star at all. It is happening in our own atmosphere. As starlight passes down through layers of moving air, warm pockets and cool pockets, fast currents and slow ones, the light bends slightly again and again, like a pencil looking bent in a glass of water. This bending is called atmospheric scintillation, and it is the same reason distant lights on a hot road seem to shimmer above the pavement. Stars twinkle because our air is restless above us, not because the stars themselves are flickering. Planets, being much closer and appearing as tiny disks rather than single points, average out that shimmer and glow more calmly. So there is something sweet in that old rhyme, "Twinkle, twinkle, little star," because the twinkle was never truly about the star at all. It was about the warm, breathing air of home. Speaking of home, let's rest for a moment on the moon, because the moon might be the most patient companion any of us have ever had. It has been rising and setting, waxing and waning for over 4.5 billion years, and the leading idea for how it formed is almost violent in its origin, and yet so peaceful in its outcome. Long ago, in the very young solar system, a planet-sized body sometimes called Theia is thought to have struck the young Earth in a glancing, enormous collision. The debris flung into orbit slowly gathered itself together, pulled by its own gravity, cooling and rounding into the moon we know. So in a very real sense, the moon is made partly of Earth, a piece of home that was thrown into the sky and then quietly kept us company ever since, softening our tides, steadying our spin, glowing back a version of daylight borrowed from the sun. The moon does not make its own light. Every silver gleam you have ever seen from it is simply sunlight bouncing off gray, dusty rock that is actually closer in color to charcoal or wet asphalt than to the bright white it appears in our sky. It looks bright to us mostly because of contrast, a pale shape floating in a truly dark background. And that face the moon always shows us, the same face, the same seas and craters arranged the same way every single night it is visible, is because the moon is tidally locked to Earth. Its rotation period matches its orbital period exactly, once around Earth, once around itself, so it always keeps the same hemisphere turned toward us like someone who has fallen asleep facing the same gentle direction, night after night, for longer than there have been oceans on this planet. Those dark patches you might notice on the moon, the ones early astronomers named Maria, meaning seas, are not water at all. They are ancient plains of solidified lava, vast basaltic floods that filled huge impact basins billions of years ago, and then cooled into smooth, dark rock, which is why they look so different from the brighter, more cratered highlands around them. If you trace them with a soft, unfocused gaze, you might start to see the shapes people have seen for thousands of years: a face, a rabbit, a woman carrying a bundle, a toad. Different cultures looked at the exact same pattern of ancient lava and craters, and each told a different bedtime story about it, which feels like proof that the moon has always been something we tell stories to, and something that listens. Let your eyes drift a little further now, toward whatever handful of very bright, very steady points might be scattered near the moon or along the horizon, because a few of those are not stars at all. They are our neighboring planets, quietly sharing our same solar orbit around the sun. Venus, when visible, is usually the brightest thing in the sky besides the sun and moon, so bright that people sometimes mistake it for an airplane or even report it as something stranger. And its brilliance comes from being wrapped in thick, reflective clouds of sulfuric acid that bounce back a huge portion of the sunlight that hits it. Jupiter, when it is up, holds a steady, creamy brightness of its own, and if you were ever to look at it through even a small pair of binoculars propped very still, you might catch 4 tiny points of light lined up near it. Its largest moons, Io, Europa, Ganymede, and Callisto, the same 4 moons that Galileo watched shift position night after night more than 400 years ago, and in watching them, quietly proved that not everything in the heavens orbits the Earth. Mars carries a faint rust-colored glow, iron oxide dust coating its whole surface, the way rust coats an old, forgotten key, and Saturn, pale and golden, is circled by rings made of countless icy fragments, some as small as grains of sand, some as large as houses, all silently orbiting in a disk thinner, relative to its width, than a sheet of paper. Now let your gaze wander to the seemingly patternless scatter of fainter stars, because that scatter is not patternless to the people who came before us. For thousands of years, across nearly every culture on Earth, people connected these distant points into constellations, shapes meant to help them remember stories, mark seasons, and navigate oceans they could not otherwise cross safely. Orion, the hunter, with 3 stars in a neat little belt across his waist, rises in a way so recognizable that sailors used it for centuries to judge direction and time of night. The Big Dipper, part of the constellation Ursa Major, points almost directly, using the 2 outer stars of its bowl, toward Polaris, the North Star, a star that happens to sit nearly still above Earth's North Pole because our planet's axis points almost exactly toward it. Polaris is not the brightest star in the sky, not even close, but it became one of the most important because it barely moves while every other star seems to wheel slowly around it through the night, a quiet anchor in an otherwise turning sky. That turning, by the way, is not the stars moving. It is us. Earth spins on its axis once roughly every 24 hours, and as it turns, the stars appear to rise in the east and set in the west. Sweeping in smooth, silent arcs overhead, the same way scenery outside a train window seems to slide past even though it is the train, not the world, that is moving. If you could take a long exposure photograph pointed at the North Star and leave the camera open for hours, you would see every star trace a perfect circle around that one still point, a spinning wheel of light with Polaris quietly at the hub. And it becomes very easy in that image to feel just how much motion is happening around us at every moment, silent and smooth and completely imperceptible to a body just standing still on the ground, feeling nothing but a light breeze and the settling cool of night. Let's talk for a while about that pale, hazy band that sometimes stretches across a very dark sky, the one that looks almost like spilled milk or a soft smear of chalk dust dragged from one horizon to the other. That is the Milky Way, and it is not a separate thing floating out there beyond us. It is us, or rather, it is the galaxy we live inside, seen edge on from the inside looking out. Our entire solar system, the sun, the earth, the moon, every planet you have ever heard named, sits inside a vast spinning disk of stars, gas, and dust called the Milky Way galaxy. A disk so large that light, moving at its impossible constant speed, takes about 100,000 years to cross from one edge to the other. When you look up at that pale band, you are looking through the thickest part of our own galactic disk, toward the crowded core where hundreds of billions of stars are gathered so densely that their combined, unresolved light blurs into that soft haze. It is a bit like standing inside a snow globe and looking sideways through all the glittering flakes at once, except the flakes are stars, and there are more of them than any of us could count in 100 lifetimes of counting. Our sun is only one of these stars, an unremarkable, medium-sized, middle-aged star drifting quietly in one of the galaxy's outer spiral arms, taking about 225 million years to complete a single orbit around the galactic center. A journey so long that the last time our sun was in this exact position, dinosaurs had not yet appeared on Earth. Everything you have ever known, every person who has ever lived, every war and celebration and quiet Tuesday afternoon has happened during a single, unfinished lap of that enormous orbit. And our galaxy itself is only one among hundreds of billions of galaxies scattered through the observable universe, some spiral like ours, some smooth and elliptical, some irregular and misshapen from ancient collisions, all of them drifting slowly apart from one another as space itself gently stretches with time. If you are patient, and the sky is dark enough, and you let your eyes stay soft and unfocused rather than sharply searching, sometimes a thin streak of light will flash silently across your field of vision and vanish before you can even point at it. This is a meteor, commonly called a shooting star, though it has nothing to do with stars at all. It is a tiny piece of rock or dust, often no larger than a grain of sand or a pebble, entering our atmosphere at extraordinary speed, tens of kilometers every single second, and burning up from the friction of hitting all that air so quickly. Most of the meteors you might ever see complete their entire fiery streak, from first spark to final fade in less than a second, and they burn up harmlessly, high above the ground, usually somewhere between 50 and 100 kilometers up, well above where airplanes fly, well above where clouds gather. On certain nights of the year, when Earth's orbit carries it through a trail of debris left behind by a passing comet, many decades or centuries earlier, we get meteor showers, nights when dozens of these tiny streaks might appear each hour, all of them seeming to radiate from one point in the sky because they are, in truth, all traveling on roughly parallel paths, the same way parallel train tracks seem to converge toward a single point far off in the distance. Comets themselves are old, icy wanderers, sometimes described as dirty snowballs, though that phrase undersells how beautiful they can become. Far out in the cold, dark edges of the solar system, they drift for thousands or even millions of years as frozen lumps of ice, dust, and rock. And then, occasionally, gravity nudges one into a long looping path that brings it closer to the sun. As it nears that warmth, the ices on its surface begin to vaporize, releasing gas and dust that streams away from the sun's pressure, forming a glowing head called a coma, and a long, faint tail that can stretch for millions of kilometers, always pointing away from the sun no matter which direction the comet itself is moving, like a scarf blown backward by a wind it cannot see. Let your thoughts settle now on the stars themselves, not just as points of light but as living things, in their own slow, patient way. A star is born inside a cold, quiet cloud of gas and dust called a nebula, when gravity slowly pulls a dense clump of that material inward on itself, squeezing it tighter and tighter until the pressure and heat at its center grow enormous enough to ignite nuclear fusion, the process of hydrogen atoms fusing into helium and releasing tremendous energy as light and heat. That ignition is the true birth of a star, the moment it begins to shine on its own rather than simply reflecting light from somewhere else. For most of a star's life, it exists in a long, stable, almost sleepy equilibrium, the outward pressure from all that fusion balancing perfectly against the inward pull of its own gravity, shining steadily for millions or billions of years depending on its size. Smaller stars, dim and red, burn their fuel so slowly and gently that some of them will still be quietly glowing long after our own sun has finished its story. Larger, hotter, brighter stars burn through their fuel far more quickly and dramatically, living shorter, more intense lives, sometimes only a few million years, before ending in one of the most spectacular events the universe offers. When a truly massive star finally exhausts its fuel, it can no longer hold up against its own gravity, and it collapses inward in an instant, then rebounds in a catastrophic explosion called a supernova, briefly outshining an entire galaxy of billions of ordinary stars combined. In the wake of that explosion, the star's outer layers are flung outward into space, seeding the surrounding nebula with heavier elements, carbon, oxygen, iron, elements that did not exist in the early universe and were only forged in the hearts of dying stars. Every piece of carbon in your own body, every drop of iron in your blood, was once cooked inside a star that lived and died long before our sun was ever born. There is a real, quiet truth tucked inside that fact, the same one a wise scientist once put into gentle words, that we are made of star stuff, and when you look up at the night sky, you are not looking at something foreign or distant in any final sense. You are looking at family, at ancestors, at the very forge that made the atoms currently rising and falling ever so slowly in your chest as you breathe. Somewhere out there, hidden from casual view but sometimes catchable through a telescope or a long, patient photograph, drift the great clouds we call nebulae, the nurseries and graveyards of stars all at once. Some, like the Orion Nebula, glow softly pink and orange, lit from within by the fierce ultraviolet light of newborn stars still wrapped in the very gas that made them, like infants swaddled in the blankets of their own birth. Others, like the delicate, glowing shells left behind by smaller stars in their final gentle stage of life, called planetary nebulae despite having nothing to do with planets, spread outward in slow, expanding rings and loops of colored gas, glowing in soft greens and blues from ionized oxygen and hydrogen, a star's last quiet exhale before it settles into a small, dense, cooling ember called a white dwarf, content to fade slowly over unimaginable spans of time. Cooling by the faintest degree, for longer than the universe has existed so far. And then there are the stranger endings, reserved for only the most massive stars, so massive that even a supernova cannot fully release the tension between their gravity and their spent fuel. These stars collapse so completely that they leave behind either a neutron star, an object so dense that a single teaspoon of its material would outweigh a mountain, spinning sometimes hundreds of times per second and sweeping beams of radiation across space like a slow lighthouse. Or, if the star was massive enough, a black hole, a place where gravity has folded so tightly upon itself that nothing, not even light, can escape its pull once it crosses a boundary called the event horizon. Black holes are not holes in the usual sense, not tears or gaps. They are simply regions where matter has become so concentrated that spacetime itself curves back on itself, and the darkness we associate with them is not emptiness, but rather the total, absolute capture of every bit of light that tries to leave. There is nothing to fear in this, lying here, safe and warm. The nearest known black hole is so far away that its influence on us is less than a whisper, less than a single grain of sand's weight pressing on the whole surface of the ocean. It exists simply as one more strange and wonderful fact tucked into the vast quilt of the sky, something to be curious about rather than worried about. The way a distant thunderstorm on the horizon can be beautiful precisely because it is far enough away not to touch you. If you tilt your attention now towards soft clusters of stars rather than single points, you might notice small groupings that seem to huddle together, like the Pleiades, sometimes called the Seven Sisters, a tight cluster of young, hot blue-white stars wrapped in the last faint wisps of the nebula that birthed them, visible to the naked eye as a small, misty smudge that has been noticed and named by cultures across the entire world, from ancient Greece to Japan to the Aboriginal peoples of Australia, each with their own gentle story about sisters, or hunters, or lost children gathered safely together in the sky. Star clusters like this are thought to form all at once, from the same collapsing nebula, which means every star within one is roughly the same age, siblings born together from the same cloud, drifting slowly apart from each other over hundreds of millions of years as the cluster's loose gravity gradually lets them go their separate ways, the way grown children drift gently from a childhood home without ever quite forgetting it. Let's rest for a while on light itself, the messenger that carries all of this to us. Every color you see in the night sky, the blue-white of hot young stars, the warm orange of aging red giants, the pale gold of Saturn, the faint green sometimes caught in a nebula's glow, is a kind of fingerprint, a signature of temperature and composition written directly into the light before it ever left its source. Hotter stars burn blue and white, cooler stars glow orange and red, and by carefully splitting starlight apart into its full spectrum, the same way a prism splits sunlight into a rainbow, astronomers can read the exact chemical elements present in a star's outer layers: hydrogen, helium, sodium, calcium, iron, each element leaving a distinct dark line in the spectrum like a signature at the bottom of a very old letter. In this way, without ever physically touching a single star, without any spacecraft ever coming remotely close, we have learned what nearly every visible star in the sky is made of, simply by patiently reading the light they send us. A little like learning the entire life story of a stranger from nothing but the sound of their voice carried gently on the wind. On certain rare and treasured nights, especially in far northern or far southern latitudes, the sky itself seems to come alive with slow, drifting curtains of green, sometimes touched with pink or violet, rippling and swaying like silk caught in an unseen breeze. This is the aurora, the northern lights in the north and the southern lights in the south, and it happens when charged particles streaming from the sun, carried on what is called the solar wind, are funneled by Earth's magnetic field down toward the polar regions, where they collide with atoms of oxygen and nitrogen high in the atmosphere. Those collisions excite the atoms, energize them briefly, and as they settle back down to their resting state, they release that extra energy as soft, glowing light, oxygen most often giving that gentle green and sometimes red, nitrogen contributing blues and purples along the lower edges. It is, in a very real sense, the sun reaching out across 93 million miles of empty space and gently touching our planet's own magnetic shield, the two of them dancing together in colors, high above the frozen quiet of the tundra, while everything below sleeps undisturbed beneath the shifting light. And every so often, the sun, the moon, and the earth line up in just the right way to give us an eclipse, one of the oldest and most awe-filled events a person can witness with their own eyes. In a solar eclipse, the moon passes directly between the earth and the sun, and because of a truly remarkable coincidence, the moon appears in our sky at almost exactly the same size as the sun, even though the sun is about 400 times larger, simply because it also happens to be about 400 times farther away. That coincidence allows the moon, during a total solar eclipse, to cover the sun's bright face almost perfectly, revealing the sun's faint outer atmosphere, the corona, glowing pale and ghostly white around a suddenly dark disk, while the sky dims to a strange twilight in the middle of the day. And if you happen to be standing in the right place, the temperature itself can be felt dropping by several degrees in just a few minutes. A lunar eclipse is gentler, slower, and far more commonly visible, happening when the Earth passes between the sun and the moon, casting its own shadow across the lunar surface, turning the moon a deep, soft copper red as the only light still reaching it bends through the edges of Earth's atmosphere. The same reddening effect that colors a sunset, borrowed and cast across 250,000 miles of space onto the surface of the moon. Let's drift now toward the quieter, slower rhythms that the sky keeps for us, the ones that shape entire years rather than single nights. The reason we have seasons at all has nothing to do with Earth moving closer to or farther from the sun, and everything to do with the gentle tilt of our planet's axis, about 23.5 degrees, leaning steadily in one direction as Earth makes its long yearly orbit. When the northern half of the planet leans toward the sun, it receives more direct, higher-angled sunlight for longer stretches of the day, and that half calls it summer, while the southern half, leaning away, calls it winter. And then, 6 months later, as Earth continues its patient circuit, the roles quietly reverse. This is why the night sky itself seems to change with the seasons, why Orion the Hunter dominates winter evenings and gives way, by summer, to the rich, dense glow of the galactic core, rising in constellations like Sagittarius and Scorpius. You are not just watching the sky rotate through a single night. You are watching Earth slowly carry you around an enormous circle every year, tilting you toward different patches of that same surrounding dome of stars, the way a slow carousel might turn a rider past a different mural on the wall with every full revolution. The moon, too, keeps a rhythm, one so old and so steady that entire calendars have been built around it. As the moon orbits Earth roughly every 27.33 days, though the cycle we see from new moon to new moon actually takes about 29.5 days because Earth itself is also moving around the sun during that time. Sunlight illuminates different portions of the lunar surface as seen from our angle here on the ground. When the moon sits between Earth and the sun, the side facing us is in shadow, and we call it new moon, invisible against the night. As it moves along its orbit, a thin sliver of sunlight along its edge grows night by night into a crescent, then a half, then a swelling gibbous shape, until, when Earth sits roughly between the sun and the moon, we see its entire sunlit face and call it full. Then the whole gentle cycle reverses, wanding back down through gibbous, half, and crescent, until it disappears again into new moon and quietly begins once more. This waxing and waning shaped some of the very earliest calendars ever created by human hands, and it still governs the timing of certain holidays and tides today. A reminder that long before clocks, before written language even, people were already reading time directly from the sky above them. Those tides themselves are the moon's quiet, invisible hand resting on our oceans. The moon's gravity pulls at Earth, and because the side of Earth closest to the moon feels a slightly stronger pull than the side farthest away, the ocean water bulges gently outward on both sides, the near side pulled toward the moon, and the far side left behind as Earth itself is pulled slightly more than the water on the opposite side. As Earth rotates underneath these two bulges roughly once a day, most coastlines experience 2 high tides and 2 low tides within about 24 hours, a slow, breathing rise and fall of the entire ocean, timed by a companion drifting quietly 250,000 miles away. The sun contributes its own smaller pull as well, and when the sun and moon line up together during new and full moons, their combined pull creates especially strong tides called spring tides, and when they pull at right angles to each other, during the moon's quarter phases, the tides are gentler, called neap tides. The ocean itself, in other words, has been slowly, rhythmically breathing in time with the sky for as long as there has been an ocean at all. For nearly all of human history, the night sky was not simply beautiful. It was essential, a map, a clock, and a compass all at once. Sailors far from any coastline used the fixed positions of stars like Polaris, or the predictable rising and setting points of certain bright stars along the horizon, to hold a steady course across open, featureless ocean where no other landmark existed. Farmers watched for the yearly reappearance of certain stars just before dawn, a technique called heliacal rising, to know when to plant or when to harvest, long before printed calendars existed to tell them. Entire migrations of birds of ancient peoples crossing vast distances on foot or by canoe were guided in part by consistent, memorized patterns overhead. The constellations we still name today, Orion, Taurus, Scorpius, Leo, were not decorations. They were tools, practical and essential, dressed up in mythology so that the practical knowledge could be remembered more easily, passed from a parent to a child the way a bedtime story is passed down, useful information smuggled gently inside something that felt like wonder. In our own more recent history, we have sent our own quiet lights up into that sky to join the ancient ones. If you watch carefully on a clear night, especially in the hour or two after sunset or before sunrise, you might notice a single, steady point of light gliding smoothly and quickly across the sky, taking only a few minutes to cross from one horizon to the other, never blinking the way an airplane does, never changing direction. This is very often the International Space Station, a football field-sized structure orbiting about 400 kilometers above Earth, home to a small rotating crew of astronauts who circle the entire planet once every 90 minutes, meaning they experience about 16 sunrises and 16 sunsets in a single day. It shines by simply reflecting sunlight, the same way the moon does, but because it is so much closer, it can appear almost as bright as some of the brightest stars, a small, fast, human-made spark keeping quiet company with the ancient, unmoving ones. Thousands of other satellites drift up there as well, some for communication, some for weather watching, some for navigation, most too faint to notice individually, all of them part of a thin, mostly invisible shell of human-made objects now wrapped gently around our entire planet. And beyond even our own solar system, in the patient decades of searching that have unfolded since the first confirmation in the 1990s, we have found thousands of planets orbiting other stars entirely, worlds called exoplanets, discovered not usually by seeing them directly, since they are far too faint and far too close to their blinding parent stars, but by watching those stars very carefully for the tiny, rhythmic dimming that happens each time a planet passes in front of them, or for the small, steady wobble a planet's gravity causes in its star's position. Some of these worlds are scorched, tidally locked balls of rock circling so close to their stars that a year lasts only a few days. Others are cold, distant giants larger than Jupiter. And a precious few sit in what scientists gently call the habitable zone, the right distance from their star for liquid water to exist, not too hot, not too cold, a Goldilocks distance, close enough to warmth to hope, without ever yet being close enough to know for certain whether anything at all is living quietly on their surface, looking back up at their own unfamiliar sky, perhaps wondering the very same things about us. Let your thoughts settle for a while on our own star, the sun, because even though it disappears every night and lets this whole quiet performance of darkness and starlight take the stage, it is still, in truth, the most important light in your entire life. It is an ordinary star, as stars go, a hot, glowing sphere of mostly hydrogen and helium, so large that about 1 million Earths could fit inside its volume, and so massive that its gravity alone holds every planet, moon, comet, and drifting piece of ice in our solar system in a gentle, endless orbit around it. At its very center, temperatures reach around 15 million degrees, hot and dense enough for hydrogen nuclei to fuse into helium every single second, releasing the steady flood of light and warmth that has kept this planet gently warmed for over 4.5 billion years. That light takes a strange, patient journey even to leave the sun at all, bouncing and scattering through the dense inner layers for possibly tens of thousands of years, before finally reaching the surface and escaping into space. And then, once free, crossing the 93 million miles to Earth in a mere 8 minutes. So the sunlight warming your skin on any ordinary afternoon may have begun its journey inside that fiery core longer ago than any human civilization has existed, only to spend its final 8 minutes crossing empty space in the time it takes to brew a cup of tea. The sun does not shine with perfect, unchanging steadiness either. It moves through slow cycles of activity, roughly 11 years long, during which dark, cooler patches called sunspots, areas where the sun's magnetic field grows tangled and intense, appear and fade across its surface, and occasionally enormous eruptions called solar flares and coronal mass ejections burst outward, flinging streams of charged particles across the solar system, some of which, days later, wash gently against Earth's magnetic field and spark the very auroras we spoke of earlier. Even our nearest star, then, is not a fixed, unchanging lamp bolted into the sky, but something closer to a slow, living rhythm, breathing in cycles that stretch across more than a decade at a time, patient in a way that makes even our longest human patience look brief and small. It can be gently dizzying in the nicest way to sit for a moment with just how large all of this truly is. So let's take that slowly, the way you might slowly sink one level deeper into a warm bath. Earth is small compared to the sun. The sun is unremarkable compared to many other stars, some of which, called red supergiants, are so enormous that if you placed one where our sun sits, its outer surface would swallow the orbits of Mercury, Venus, Earth, Mars, and reach out toward Jupiter. Our sun is one of several 100 billion stars in the Milky Way galaxy. The Milky Way is one of perhaps 2 trillion galaxies scattered throughout the observable universe, each containing, on average, hundreds of billions of stars of their own. And the observable universe itself, the farthest we could possibly see even with our best instruments, spans about 93 billion light-years across, not because the universe is only that old, but because space itself has been quietly stretching and expanding this entire time, carrying distant galaxies farther away from us even as their old light continues its long journey toward our eyes. There is no need to hold all of that at once, no test at the end of this, no number you need to remember. It is enough to simply feel for a moment how large the space is that surrounds this small, warm room you are lying in right now, and then to feel just as strongly how safe and specific and entirely enough this particular moment is, right here, regardless of all that vastness quietly humming outside it. Because here is a small, comforting truth tucked inside all of this immensity. The universe does not need you to understand it in order for it to hold you gently within it. The same laws of gravity that shape galaxies also shape the slow, steady pull that keeps you resting against this mattress. The same physics that lights a star also warms this room, distantly, borrowed originally from that very sun now resting below the horizon on the other side of the world. You are not separate from any of this. You are a small, warm, breathing part of the same universe that grew the stars, and right now, your only task, your only assignment under this entire sky, is to let your breathing slow, to let your shoulders soften further into the pillow, and to let all of this vastness simply become something quiet and kind that holds you, rather than something you need to figure out. Let's wander for a while longer through the old star pictures, the ones people have leaned on for thousands of years. Because there is something wonderfully human about the way our ancestors looked at the exact same random scatter of light, we still see tonight and decided, gently and deliberately, to turn it into stories. The band of constellations that the sun, moon, and planets all appear to travel through across the year, the zodiac, was mapped out by ancient Babylonian astronomers who divided that path into 12 sections, each one roughly a month wide, and gave them names: Aries the ram, Taurus the bull, Gemini the twins, Cancer the crab, Leo the lion, Virgo the maiden, Libra the scales, Scorpius the scorpion, Sagittarius the archer, Capricornus the sea goat, Aquarius the water bearer, and Pisces the fish. These were practical calendars long before they were anything mystical, a way of marking where the sun appeared to sit against the background stars during each part of the year, useful for tracking planting seasons and festivals, later wrapped in myth so the pattern would be easier to remember and pass down. The same gentle trick a parent uses when turning a chore into a game for a sleepy child. Orion, the great hunter, is probably the easiest constellation for a beginner to find, with its neat, evenly spaced belt of 3 stars glowing in a near-perfect line, flanked by 4 bright stars marking his shoulders and knees, including the reddish supergiant Betelgeuse, a star so enormous and so near the end of its long life that astronomers expect it to end in a supernova at some point, though it could be tomorrow or it could be 100,000 years from now, and either way. Its light left the star roughly 640 years ago, meaning it may have already exploded, and we simply have not yet received the news. Nearby, Sirius, the brightest star in the entire night sky, sits in the constellation Canis Major, the great dog, faithfully trailing behind Orion, and ancient Egyptians once timed the flooding of the Nile by watching for the day Sirius first became visible again in the pre-dawn sky after a period of being lost in the sun's glare. A yearly reunion between one particular star and the people who depended on its return. The Southern Hemisphere holds its own quiet treasures unfamiliar to many in the North. The Southern Cross, a small, tidy constellation used for centuries by sailors below the equator the way Polaris is used above it, along with the Magellanic Clouds, 2 small companion galaxies to our own Milky Way, visible to the naked eye from far enough south as soft, glowing smudges, named for the explorer Ferdinand Magellan though known, and used for navigation by peoples of the southern oceans long before that. It is a small, comforting thought that no matter where on Earth you happen to be lying tonight, someone, somewhere, is looking up at their own familiar patch of that same enormous sky, tracing shapes their own grandparents once traced, finding comfort in the same unhurried, ancient dependability that you are resting in right now. Let's think for a moment about how we came to know so much of what we have talked about tonight, because none of it was learned quickly or carelessly. For most of history, all astronomy was done with nothing but the naked eye, careful record-keeping, and enormous patience. Ancient astronomers in Babylon, Egypt, China, and the Maya recording the positions of planets and the timing of eclipses across many generations, slowly noticing patterns that no single lifetime could have revealed alone. Everything changed gently but permanently around 400 years ago, when the telescope was first turned toward the sky, and a curious, careful observer named Galileo Galilei saw craters on the moon, 4 small moons quietly circling Jupiter, and the phases of Venus, evidence that quietly, patiently dismantled the old idea that everything in the heavens revolved around the Earth. In the centuries since, our instruments have grown larger, gentler, and far more sensitive, from simple glass lenses to enormous mirrored telescopes perched on remote mountaintops where the air is thin and still, to observatories launched entirely beyond the atmosphere, orbiting quietly in space where no twinkling air can blur their view at all. One such observatory, a space telescope named after the astronomer Edwin Hubble, spent decades capturing extraordinarily deep, clear images of galaxies so far away that their light had been traveling toward us for billions of years, and its successor, a newer infrared telescope with a name honoring a different pioneer, unfolded its gold-coated mirrors in the cold darkness far beyond the moon's orbit and now peers even deeper into the past, catching the faint, stretched light of some of the very first galaxies to ever form, back when the universe itself was still young and dim and gathering itself together for the very first time. And further back than even those earliest galaxies, if you had a way to see it, which in a sense we do, there is a faint, ancient afterglow filling the entire sky uniformly in every direction, called the cosmic microwave background, the leftover heat from an incredibly hot, dense, early universe cooling down for the first time. Radiation so old that it has been traveling toward us, uninterrupted for over 13 billion years. The oldest light there is older than any star, older than any galaxy, a faint, warm whisper from the very beginning of everything, still gently arriving all these billions of years later. The same patient way starlight has always arrived, one quiet photon at a time. Let's rest for a while now on the color of the sky itself, since it changes so gently through the evening that it is easy to miss just how much is happening in that change. During the day, sunlight, which is really a mix of every color at once, scatters off the tiny molecules of our atmosphere, and blue light, traveling in shorter, choppier waves, scatters far more easily than red or orange light, which is why the daytime sky glows blue in every direction rather than staying dark the way space itself actually is. As the sun sinks low toward the horizon at dusk, its light has to travel through a much thicker slice of atmosphere to reach your eyes, and along that longer path, even more of the blue light scatters away and out of your line of sight before it arrives, leaving behind the warm reds, oranges, and pinks that paint a sunset. Twilight itself unfolds in 3 gentle named stages: civil twilight just after sunset when there is still enough light to move about easily outdoors, nautical twilight a little later when the horizon grows hard to distinguish from the sky, and astronomical twilight last of all, when the sky finally grows dark enough for even the faintest stars to appear, and true night settles in fully, unhurried, the way a held breath is finally, slowly let out. Far beyond the planets we have already visited in our thoughts tonight, past Saturn's rings and Jupiter's moons, there drifts a vast, sparse ring of small icy leftovers called the asteroid belt, sitting mostly between Mars and Jupiter, made up of countless rocky fragments, remnants from the solar system's early, chaotic formation that never quite managed to gather themselves into a full planet, kept stirred and scattered by Jupiter's enormous gravity before they ever could. And farther out still, beyond Neptune's orbit, lies the Kuiper Belt, a wide, cold ring of icy bodies including the dwarf planet Pluto, drifting so far from the sun that sunlight reaching it is thousands of times fainter than what reaches Earth, a twilight that never brightens into true day. And beyond even that, wrapping the entire solar system in a vast, thin, spherical shell reaching perhaps halfway to the very nearest other star, astronomers believe there exists the Oort cloud, a distant reservoir of icy fragments so far out that some of its members take millions of years to complete a single orbit around the sun, occasionally nudged loose by the passing gravity of another star, and sent tumbling slowly inward, arriving, after a journey longer than human history itself, as one of the comets we spoke of earlier, trailing its glowing tail across our sky like a very old, very patient letter finally being delivered. It is worth resting for a moment, too, on how far our own small emissaries have traveled into all of this. 2 spacecraft named Voyager, launched in the late 1970s to take advantage of a rare, favorable alignment of the outer planets, are now the most distant human-made objects in existence, having long since passed beyond the edge of the sun's influence and out into interstellar space itself. Still, even now, faintly calling home with a radio signal so weak that it takes light itself, moving at its full, unimaginable speed. Over 20 hours to carry that whisper back to the antennas listening for it on Earth. Each spacecraft carries a golden record, an actual phonograph disc engraved with sounds and images meant to describe our planet, greetings spoken in dozens of languages, bird song, laughter, music. A message in a bottle cast into the vast, dark ocean of space, in case anyone someday, somewhere impossibly far from here, ever finds it drifting by and wonders who sent it. And if you ever wonder whether anyone out there might be wondering the same things we are, you are in good company. For decades, radio telescopes, enormous dish-shaped ears built to listen for the faintest whispers of energy crossing the universe, have occasionally been pointed not just at galaxies and nebulae, but quietly, patiently, toward the possibility of a deliberate signal, some structured pattern in the static that might mean another mind, somewhere out there, once looked up at its own sky the way you are looking up in your mind at yours right now, and decided to reach out. Nothing certain has ever been found. No confirmed voice has ever answered back. But the listening itself continues, gentle and unhurried, the same patient kind of hope that has always lived quietly underneath every single story we have ever told about the sky. Let's rest for a moment on a stranger, quieter truth, one that most of the universe's mass and energy is not made of anything we can actually see at all. Everything we have talked about tonight, every star, every planet, every glowing nebula, every galaxy, is made of what scientists call ordinary matter. And yet all of that ordinary matter together makes up only a small slice of everything that exists. The rest is something called dark matter, an invisible, unlit substance that neither shines nor blocks light, detectable only through the gentle, patient tug of its gravity on the stars and galaxies we can see, holding entire galaxies together with a firmer grip than their visible stars alone could ever provide. And beyond even that, filling the vast spaces between galaxies, there is something called dark energy, a mysterious, steady pressure that seems to be gently, quietly pushing the universe apart, causing distant galaxies to drift away from one another a little faster with every passing year. We do not fully understand either of these things yet, and there is something almost comforting in that admission, that even our best astronomers, with their enormous telescopes and their careful decades of patient watching, are still, in their own way, lying back and looking up at a mystery larger than themselves, still curious, still gentle in their not knowing, the same way you are allowed to not know everything tonight and rest anyway. Even our own sun, steady and dependable as it has been for over 4.5 billion years, will not shine forever in its current, gentle way. Many billions of years from now, long after every person alive today, and their children's children's children have lived and rested and been remembered, the sun will begin to run low on the hydrogen fuel at its core, and it will swell, slowly and majestically, into a red giant, growing so large that it will likely swallow Mercury and Venus entirely and reach out toward a badly scorched Earth. And then, gently rather than violently, since our sun is not massive enough for a supernova, it will shed its outer layers in soft, expanding shells, briefly becoming one of those planetary nebulae we spoke of earlier, glowing softly in space, before settling down into a small, dense, slowly cooling white dwarf, content to fade by the faintest degree, for longer than can be easily imagined. This is not a sad ending, not really. It is simply the sun's own long, unhurried bedtime, arriving after a day that will have lasted many billions of years, following the same quiet pattern every star follows, waking, shining, resting, at its own enormous, patient scale. And if you let your mind drift out even further than that, past the sun's ending, past the eventual slow fatting of every star that will ever form, some astronomers gently describe an extremely distant future for the universe itself, one so far ahead that comparing it to tonight is like comparing the age of the universe to the length of a single breath, a future sometimes called the heat death of the universe, in which every star has finally burned out, every black hole has slowly evaporated, and the universe settles into a vast, cold, extremely dim stillness, spread thin across an unimaginably large space. It is not something to carry any worry over, not tonight, not for many, many lifetimes of lifetimes to come. It is simply one more soft, distant shape at the very far edge of the story, the way a bedtime story might gently mention, without any fear at all, that someday, far off, the story will have an ending too, and that this is simply part of what makes a story, rather than something to keep you from closing your eyes right now. Let's slow down even further now, because There is no reason to rush any of this. Think for a moment about how still the sky actually feels from where you are lying, even though almost nothing in it is truly still at all. The Earth beneath you is spinning at roughly 1,000 miles an hour at the equator, and even faster than that around its orbit of the Sun, moving at about 67,000 miles an hour through space. And the entire solar system, Sun included, is drifting through the Milky Way at roughly 500,000 miles an hour as it makes its long, slow lap around the galactic center. And the Milky Way itself is drifting through the wider universe at well over 1 million miles, an hour relative to the ancient light of the cosmic microwave background. You, right now, wrapped in blankets, feeling almost perfectly motionless, are in fact hurtling through space at a speed almost too large to hold in the mind. And yet none of it can be felt, none of it disturbs the stillness of this exact moment, because everything around you is moving together, smoothly, gently, in the same direction, the way a sleeping passenger on a train feels no motion at all as long as the ride stays even and calm. That is a small, private kind of miracle, that you can be moving faster than any bullet ever fired and still feel correctly, that you are simply lying still, safe, and at rest. Think too about how old the light reaching your eyes on even the most ordinary clear night truly is, gathered together from wildly different moments in time, all arriving at once, as if the sky were a single page containing sentences written in many different centuries. The moonlight is a little over a second old. Sunlight, when the sun was still up, was 8 minutes old. Starlight from the nearer stars might be 4, 8, 20, 40 years old. Light from more distant stars within our galaxy might be hundreds or thousands of years old. And the faint smudges of the most distant galaxies visible even in a large telescope carry light that began its journey millions or even billions of years before the Earth itself had finished forming. Every time you look up, you are reading a letter assembled from many different eras all at once, delivered instantly and effortlessly to your open, upturned eyes, and requiring nothing from you at all except the willingness to simply look, or tonight, the willingness to simply imagine looking, eyes closed, sky held gently in the mind instead. There is an old, comforting idea, repeated in many cultures in slightly different words, that the same sky covers everyone, that the same moon rising over your rooftop is also rising, a little earlier or a little later, over every other rooftop on Earth, that the same handful of bright, ancient stars have been watched by every grandparent, every great-grandparent, every ancestor stretching back further than any family tree could ever record, all of them at some point. Lying outside on a warm night or a cold one, looking up at this same unchanging arrangement of light, and feeling some version of the exact same hush you might be feeling right now. Whatever else is happening in the world, whatever else feels large or unsettled or unfinished, the sky keeps this one quiet promise. It returns every night, unhurried, dependable, patient, asking nothing of you except rest. So let the stars stay exactly where they are, wheeling their slow, silent circle around a still point somewhere near the North Star, needing no help from you tonight. Let the moon keep its patient watch, borrowing its glow from a sun that has already set on your side of the world, holding the tide gently in and gently out somewhere across an ocean you may never see. Let the galaxies keep drifting apart at their own unhurried pace. Let the nebulae keep quietly gathering themselves into stars that will not finish forming for 100,000 years. Let the ancient light of the very beginning of everything keep arriving, softly, in every direction, whether anyone is awake to receive it or not. None of it depends on you staying alert to witness it. It was here long before you, and it will be here, unchanged in all the ways that matter, long after you have drifted, finally and completely, into sleep. Rest now, my friend. The sky does not need watching. It only asks to be trusted, the way an old friend is trusted to still be there in the morning. Let your breathing grow slow and even. Let your thoughts loosen and drift the way starlight drifts across 100,000 years of empty, patient space. There is nothing left to understand tonight, Nothing left to hold on to, only the soft, dark quiet above you and the soft, warm quiet around you, meeting gently in the middle, right here, right now. Sleep well under all of it. Sleep well held by all of it. Good night.